Welcome to this tutorial presented by oraclecoach.com. This is Claire Rajan, and in this tutorial I'll demonstrate how SQL join statements are written in Oracle. The theory behind joining tables in Oracle was discussed in the video tutorials titled Joining Tables Part 1 and 2, and it might be a good idea to first watch those tutorials to get a complete understanding of how joining of tables is done. In this tutorial, I'll show you how each type of join statement is written in Oracle with a quick review of the most important points relating to each type of join. I'll be showing you how the join is done using traditional syntax where the join's condition is written in the where clause of the SQL statement. The specific joins that will be demonstrated in this tutorial are the equi-join, non-equi-join, outer join, Cartesian join, and self-join. I'm going to first launch SQL Developer. I'm connected as the user HR through a connection called C1. Now, before I start writing the queries on each type of join, I'm going to take a few minutes to look at some data in some of the tables that will be referenced in this tutorial. The first table I'm going to pull up is the table called Employees. The Employees table contains information or details about employees. Every employee has an ID, a unique value that is associated with the employee. An employee has a first name, an employee has a last name. I'm now going to just scroll through the output and concentrate only on the columns that are of importance to us. Over here, we have a salary column, which is the monthly salary of an employee, and we have a column called the department ID, which identifies the department that the employee belongs to. The department ID column is an important column in this tutorial because it's going to be referenced in many of the different examples. I'm now going to pull up the second table known as the departments table. The departments table contains details about the different departments in the company. The table has got columns such as the department ID column, which is unique to each department. Then we have a department name, which is the name of the department, and then you have a manager ID column, which identifies the number of the employee that manages the department. So there is a relationship between the departments table and the employees table based on the manager ID column. An employee of the company is a manager of a department. Now the next table that I'm going to pull up is the table known as the sal grade table. The sal grade table contains details about salaries and grades. The sal grade table has got three columns: grade, min sal, and max sal. Now, an employee's salary is based on an employee's grade is based on the salary that the employee earns. Here we have three columns: grade, min sal, and max sal. And if I had to understand the data in the table, a grade A would be assigned to an employee whose salary lies within the min sal of 1, and a max sal of 10,000 would be assigned a salary of B if the salary was between a min sal of 10,001 and 20,000, and so on. Now I'm going to go back to the table known as the employees table, and I'm going to pull up the first employee number 1, where the salary of that employee was 24,200. Now, if I had to find out what the grade of that employee would be, that would be based on the salary. And because 24,200 falls within the range of 20,001 and 30,000, the grade of that employee would be C. So these are the three tables that we are going to work with in this tutorial. I'm now going to go to the SQL worksheet window, where I'm going to write different types of queries based on the different types of joins available in Oracle. The first type of join is called the equi-join, and it retrieves data from multiple tables based on a condition of equality between the values in the tables. The query that I'm going to write now will display the first name of an employee and the name of the department that the employee belongs to. So the query is going to be select the first name, because that's one of the columns I want to see in the output. I also want to see the name of the department that the employee belongs to. First name comes from the employees table, department name comes from the departments table. So I'm going to mention the two table names one after another, separated by a comma. And what I will then have to do is identify the condition that joins the two tables. It's known as the join condition, and the join condition in a traditional syntax is written in the where clause. So my condition to join the tables was that the employee's department ID was equal to the department table's department ID column. So my equi-join that I've written is select first name comma department name from employees comma departments, where employees dot department ID is equal to the department table's department ID column. If I now execute this statement, I'm able to see each employee's name and the department name that they belong to. So this was an example of an equi-join. The next thing that I'm going to do is modify this select statement to include table aliases. A table alias is a substitute name that is created for a table in a select statement. It's temporary and it's usually created when you want to shorten a long table name. And it's going to be valid only for this particular select statement as long as it is executing. It's temporary in nature. Now let's say we have two tables over here, the employees table and the departments table, and they both seem to have long names. And suppose I want to shorten the names, and I don't want to have to keep writing employees and departments over and over again in my select statement. I want to be able to work with shorter names. So what I choose to do is create an alias for the employees table as E, and I create an alias for the departments table as D. Now, aliases are defined in the from clause beside the name of the table, separated by a blank space. Now, if I execute the statement as it is, I'm going to get an error. The reason being, once you have defined an alias, it becomes mandatory for you to use the alias in place of the name of the table wherever the table name is referenced in the query. Now, in my join condition, I have a where clause that references the table name, employees and departments. So that would mean I would have to remove the word employees and use the alias E. I'll have to remove the name departments and use the alias as D. I'm now going to execute this select statement, and what we get is the output that was identical to the previous output, where I was able to see the first name and the department name for each employee. The next thing I'm going to show you is how the outer join is performed. Now, let's first have a look at the employees table, and I'm going to scroll through this output and to show you the total number of rows which are in the employees table. The employees table has a total of 107 rows. I'm going to go back to the query that I wrote that was the result of the equi-join, and I'm going to scroll through this query result to see the total number of rows that were actually retrieved by the equi-join. The number of rows that were retrieved was 106. That means one specific employee's record was not retrieved or not displayed by the equi-join. The specific row that was not displayed by this result was for the employee who did not have a department ID. Now I've taken you back to the employees table, and I'm going to scroll through the output until I find a department ID that takes a null value. Now if I go and have a look at what the name of that employee was, the name of the employee who did not have a department ID value was Kimberly. Maybe the department has not yet been assigned to this particular employee. And what happened when you wrote the equi-join was because the department ID in the employees table was null, it did not have a corresponding matching value in the departments table for it to be able to display it in this equi-join's output. What if we wanted to see the names of the employees who had a department name associated with them, as well as the employee who did not have a department ID associated with them? In that case, what you are trying to do is, over and above the equi-join that has been written in this written over here, we want to pull up additional information. We want to be able to see the first name of the employee who does not have a corresponding department name associated with them. And the type of join that will give you that kind of an output is called as an outer join. An outer join is always written over and above an equi-join where you are trying to get additional information from one of the tables. In this particular example, what I want to be able to see is to see the name Kimberly appearing as the first name, having no matching department name in the output. That means the department name should take a null value for the first name being Kimberly.